Welcome to the second part of the Qualitative Biomechanics lecture videos. So now that we have an understanding of qualitative biomechanics and we know what a skill is, in this lecture video, we'll learn about the steps that are involved in qualitative biomechanics, different important guidelines when we're evaluating a movement, and then finally how to identify and evaluate errors in technique. There are many ways and procedures that we could take to analyze a movement. I'm going to present the one that's used in the textbook, and that includes procedures that are common to existing methods, and it provides sort of this systematic way of biomechanically analyzing human movement. So this method that I'm showing you here involves 4 steps. The first is description. And in this description step, you develop this theoretical model of the most effective technique, and then you describe what it would look like. So you determine what you want to see when you're observing your students or your athletes. The second step is observation. So in this step, you observe the performance of your student or your athlete, and you determine what that person's technique actually looks like. In the third step, that's evaluation. You compare the ideal technique that you figured out in the description phase to the observed performance that you just figured out in the second stage. So you're comparing or evaluating and identifying the errors that you see in your student or your athlete's performance. And then the fourth and final step is instruction. So in this step, you want to educate your athlete or your student by providing feedback and then instructions necessary to correct whatever errors you identified. So let's dive a little deeper into each of these steps now. Why do we do qualitative analyses? Who conducts them on a regular basis? What do you think is the answer to this question? So as a coach, a teacher, a therapist, or any other human movement professional, when we're evaluating performance, we should be able to distinguish between what's important and what isn't important in that movement, what is correct versus what's incorrect, what's possible, what's not possible, what's effective, what is safe. There's so many things that we need to be able to distinguish when we're analyzing a movement. So before performing any evaluation of a skill or any other human movement activity, you should have some familiarity with that skill. And this is absolutely necessary if you're going to propose the ideally effective technique for that skill. At the very least, if you're analyzing a sports skill, you should know the rules for that sport because rules impose constraints. So if you don't know what the constraints are, you may suggest improvements in technique or equipment that are considered cheating or illegal according to the rules. Some examples of this would be the distance of the pitching mound in baseball. There's a reason why you have to stand that far away. Same as a free throw line in basketball. You would be a lot better if you could, or I would be anyways, if I could shoot from much closer, but that would be breaking the rules. And so that can't be a suggestion for an effective improvement of the skill. So once you have some fundamental knowledge about the skill, then you next have to identify the purpose or the goal of the skill and interpret it in terms of biomechanical terms that we have now learned. Refer back to the week 1 videos if you're unfamiliar with this. So the purpose of the skill is its desired outcome, the measure of performance or success, or the performance criterion. So sometimes the purpose is really obvious and easy to identify. For example, the outcomes of all track and field events are determined objectively by answers to the questions like how fast, how far, how high. Other skills are not so obvious. The purpose of a tennis serve or a triple axel might be a little less clear. There are 2 types of goals or purposes. So the first is a practical goal, and the second is a mechanical goal. So a practical goal is specific to the context of the game. For example, scoring a goal, impressing the judges, or completing a flip. And a mechanical goal is related to the biomechanical principles. So, for example, a goal, like a mechanical goal, could be to increase linear velocity, increase momentum, decreased moment of inertia. Now, I know that these terms aren't necessarily familiar to you yet, but don't you worry, we will be learning about all of them. But those are more mechanical goals. So the goal here is more to change something in a biomechanical way about the human body. So these are some examples of practical and mechanical goals that are involved for the same skill. So just so that you can compare, visually or by reading this, what the difference is between a mechanical and a practical goal. So for a tennis serve, for example, the practical goal is to serve a point. And the mechanical goal would be to increase the speed and the accuracy of the serve. In a football tackle, the practical goal is to protect the quarterback, and the mechanical goal is to decrease the opponent's stability and velocity. So hopefully this makes sense. I'll let you read the rest, but there's a very distinguishable difference between practical and mechanical goals, and it's important that you're familiar with the difference between the two. Okay, so the next step is to identify the characteristics of the most effective technique. So this can be done two ways. The first involves an assessment of traditional techniques. So here you make the assumption that the traditional technique exhibits the most effective technique to execute the skill. So then you need to determine which aspects of that traditional technique are important and which ones aren't. And you can do this two ways. First, you should observe as many performances by elite or professional athletes, as many performances by those who know what they're doing. And then you try to identify the actions and the positions that are common to all of these athletes. So that's the traditional techniques approach. The second way to identify the characteristics of the most effective technique are simply to look at coaching and teaching materials that are related to that skill. Okay, so that's all the information for step one of the analysis, which is describing the ideal technique. Now, the next step of that qualitative biomechanical analysis is to observe the performance. So visual observation is obviously the primary basis for most qualitative biomechanical analyses, but simply observing someone is not enough. You have to actually plan your observation in advance, carefully considering things like who you'll be observing, the conditions under which that person will be performing, where the person will perform the skill, where you will be observing the skill from, and what specifically you're looking for, which hopefully you have an idea based on step one. So who you will observe may affect the manner in which you observe and conduct your analysis. As skill level increases, the size of observable error in technique decreases, as does the variability in the performance. So novice performers of a skill exhibit errors that are usually more easily recognized, but that may not be repeated from one performance to the next, because they're so variable in the way that they're performing the skill. So their performances could be so variable that a detailed analysis would be really painstaking and futile. So instead, your observation should be directed at identifying their sort of gross or major errors in each performance. Now, on the other hand, the errors of highly skilled athletes will be minor. So as the observer, you must pay more attention to the details of their technique. Now, ideally, the environment in which you watch your students or your athletes perform should be carefully controlled. So you should try to duplicate as closely as possible the environment in which the performance would normally occur. So an actual competition may be the best environment for an athlete because it's where that athlete normally performs the skill, but it may not be the best environment for the observer. So the best locations for viewing the performances may not be available during a competition, or they may be blocked by an official or another athlete. Um, on the other hand, if you control the environment by making the athlete perform their skill in a controlled lab setting, like you see here on the left, then they may not be able to perform the skill as naturally. So there has to be some sort of compromise to simulate the normal performance environment, but also minimize distractions and make it possible to observe the performance. So your vantage point when observing the performance is important because it affects what parts of the performance you'll see. Hopefully you have not forgotten the planes of motion that we learned in week 1 because those are very useful here. So first, you need to determine if the activity has a principal plane of motion. If most of the movements occur in the same plane, then you should be positioned perpendicular to that plane. So activities like running, long jump, a free throw in basketball, backstroke and swimming, those are all examples of activities whose movements occur mainly in the sagittal plane. So that means that you would want to position yourself perpendicular to the sagittal plane for those movements. Okay, so next you need to decide how close you want to be to the action. So a more distant view is desirable if you're evaluating the quality of the performance as a whole. But if you're only evaluating certain aspects of the performance, then you want to be closer so that you have a closer view of the performance. Either way, you want to be positioned far enough that you can see the movements of interest in your field of view without having to move your eyes too quickly to track them. Most activities have multiple planes of motion and they usually require multiple viewing positions. Your initial position for observing these activities is determined by the part of the skill that is most important to you, which you should have uncovered when you established your theoretical model in step 1. Your viewing direction should always be perpendicular to this most important part of the skill. And then subsequent observations may then be from different vantage points that give better views of other components of the skill. If possible, it's ideal to have a video recording of the performance from each of the different viewing positions, because with viewing recordings of performances, then you can view the same trials repeatedly without having to fatigue your athlete or your student. And the video is also useful when you're providing feedback to them. So, like I said, generally you'll have to view several performances or several replays of the recorded performance. So, during the first trial, you want to get a general view of how the athlete is performing. And then during subsequent trials, the movements or the actions that you previously identified as characteristics of the most effective technique should guide your observation. So, these are some of the features that you can look for. Things like the position of the body or the body segments at crucial moments during the performance, the duration and the range of motion of the body and its segments, the velocity and the acceleration of segments, and the timing of body segment motions that are relative to each other. So those are all different cues that you can look for when you're observing a performance. Okay, step 3. Once the errors or the deficiencies have been identified, then they should be evaluated to determine the focus of the correction. So you need to prioritize the errors that you want to correct based on several concerns, like whether the error exposes the performer to the danger of injury. Obviously, this should always take priority. Who the person is, who the client is, how easy it is to correct the error. If the error is the result of another error that occurred earlier, then you want to target that earlier error. Also, how great of an effect the error has on performance, and if the error is the result of poorly designed or inappropriate equipment. Okay, the last step is to actually instruct the performer by correcting the errors or the deficiencies that you just identified in step 3. So this instruction is what most people think of as teaching or coaching. And the fundamentals of effective instruction are not necessarily biomechanical in nature. They're more sort of motor control and sports psychology related. So to correct errors in performance, you must do 3 things. First, you must clearly communicate to the athlete or the student what they did incorrectly. They need to know what they did wrongly, right? Then second, you clearly communicate what you want them to do. So what that ideal technique or that improvement would be. And then finally, you figure out how the performer can correct these errors. So like I said, these steps aren't really biomechanics related. So this is as far as we're going to go in terms of coaching people to improve their performance. But it's still important for you to know that there's a logical flow to correct movements. Okay, so by this point, we should now have a good understanding of what qualitative biomechanics is and how to conduct this sort of basic skill observation, what those steps are. In this video, we learned about those steps. We talked about important guidelines when we're evaluating a movement and then how to identify and evaluate errors in technique.